How does orbital insertion put a spacecraft into orbit? Imagine sending a spacecraft on a journey to another planet or around Earth, and then suddenly, it needs to settle into a steady path around its target. That moment is called orbital insertion. It is a vital step that makes sure the spacecraft stays in space, rather than flying past or crashing down. After launch, the spacecraft usually travels on a transfer orbit, which is a curved path that brings it close to the celestial body. To get into orbit, the spacecraft performs a maneuver called an orbit insertion burn. This involves firing its engines to change its velocity, which is how fast and in what direction it moves. This change in velocity is called delta V. The main goal of the burn is to slow down the spacecraft if it is approaching at a high speed. Most of the time, the engines fire in the opposite direction of travel, which is called a retrograde burn. By slowing down, the spacecraft gets pulled into the gravity of the planet or moon and begins to orbit. When the spacecraft slows enough, it is captured by the body's gravity and enters an elliptical orbit, which is like an elongated circle. This initial orbit is often quite stretched out, called a capture orbit. From there, the spacecraft can perform more burns to make the orbit more circular or adjust its height and tilt. There are different ways to perform orbital insertion. The most common is the rocket propulsion burn, where the main engine fires to reduce speed. Some spacecraft use low-thrust engines that fire continuously over a longer period, which saves fuel but takes more time. When the target has an atmosphere, the spacecraft can use atmospheric drag to slow down, a method called Aerospace. This technique uses the planet's atmosphere to help slow the spacecraft without needing a big engine burn. Once in orbit, the spacecraft might need to perform more maneuvers. These include Hohmann transfers, which are efficient ways to change the size of the orbit, and plane changes to tilt the orbit to the desired angle. Sometimes, the spacecraft needs to sync up with other satellites or targets, so it performs phasing maneuvers to adjust its orbital period. In simple terms, orbital insertion is all about carefully controlling the spacecraft's speed and direction. By firing engines at just the right moment, it gets captured by the gravity of the celestial body and settles into a stable orbit. This step is essential for satellite deployment, exploring planets, or even sending humans into space. Without it, the spacecraft would just fly past or fall back down. It's a precise dance of physics and engineering that makes space missions possible.